Hello everyone and good afternoon. Thank you for joining us for our webinar on Anyone Can Be a Data Scientist. And we'll present this webinar using a case study. The webinar is being hosted by the DevMasters. The DevMasters is a data science and artificial intelligence training company providing training for data science and artificial intelligence in the cities of Irvine and Santa Monica. We are based out of Southern California, and we welcome you to our webinar. Thank you very much again for joining us. My name is Zia Khan, and I work for the DevMasters as a data scientist. I actually have a background in cloud technologies. I worked for Bell Canada in Canada for about 10 years as a cloud specialist. My role there was to help companies migrate their on-prem applications from on-prem to public cloud. And after working there for many years, I just got a little bit tired of doing the same thing over and over again, and I wanted to start a new or do something different. And for doing something different, what I decided to do was that I had options of going either in security or in data science, and I preferred data science because it's a near field. It actually gets you excited when you're looking at different challenges all the day and every day. So I decided to move into data science about 3 years back, and then I was based out of Vancouver, and I figured out that about 37% of the data scientists around the world live in California. So I decided to move to California, and hence I came here last year. When I came last year, I joined the DevMasters, and I've been working with them from that time. So that was a little bit about me. Now I'll pass the mic over to Kate Ta to introduce herself.
Hello, everybody. My name is Kate Ta. I'm also a data scientist with the DevMasters. And a little bit about me. My background is in probability and statistics. I have always liked data. I always find myself affiliated with data and the type of information and analysis that we can utilize just by using some statistical applications with data. And it was only natural for me to become a data scientist because all the data is the most important part about data science, and that's the part where I love the most. So it was a natural progression into data science, essentially. And
so just to add a little bit about the company as well for the company introduction. So as I said, that we are based out of Irvine, and the city of Irvine has been kind enough to award us a couple of awards in 2016. You can see them on the screen, at the top screen there, for specialty schools, special education, as well as for better or small business excellence. So we are really thankful to the city of Irvine for introducing these awards to us. So thank you very much, Kate. So Kate, what's the agenda for today? What are we going to do?
For today's agenda, we started off with about 5 minutes of introduction that we've already gone through. The next 15 minutes will be answering the question, what is data science? And we'll walk you through some real industrial applications of data science in order to help solidify where data science can be used. And we'll open up for Q&A for 5 minutes based on that information. And then we'll move on to the case study and basically explaining to you how we would go about with a data science project, and then at the end show you how we would actually be able to teach you data science, basically our approach. And we'll open it up for Q&A again. And just a quick thing to note, that on the side you see that there's if you stay for the end of the webinar and ask us questions during the last Q&A, we'll definitely send you a coupon for $500 off any of our programs. And there's also a special offer for early signups, but again, you would have to stay at the very end and ask us the question at the last Q&A in order to qualify for that. Okay.
All right, thank you, Kate. So that's great. So let's get started. So the question that we get asked a lot is that how do I become a data scientist, or what do I need to know if I want to be a data scientist? So in our opinion, these are the skills that we believe that are required to become a data scientist. So in the top right corner, you see that you do need to have computer programming skills. There are quite a few point-and-click tools available that will help you do data science or some parts of data science, just like Tableau and SPSS and SAS. Those are all great, exceptional tools, but most of them are commercial tools, so they do have some licensing cost attached to those. If you're looking for an open source tool like Python or R, those tools do require some computer programming skills, and then integration with other systems like front-end systems or back-end systems also require you to have some programming skills. So we believe that you do need programming skills. The second on the lower right-hand side is statistics. So really, you cannot get away with maths and statistics because data science, the backbone is stats. All the algorithms are statistical algorithms, and that help you analyze the data and maybe make predictions on those. So stats is required as a key component of data science. Now, on the lower left-hand side, telling a story or communication is also a vital part of data science, because whatever you find in your data, the patterns, the analysis that you do of your data, that has to be communicated back and told as a story to maybe stakeholders, to a customer, to your manager, or to your company senior management of whatever you found in your data. So those are all required skills. Now, the top left corner, domain expertise, that is another part of data science which is very unique, because data science is not one-dimensional kind of learning. As you can see, that there are kind of 4 different discrete dimensions or angles that you need to know to be a data scientist, and domain expertise is one of them. Let's take an example. For example, if you have a healthcare data set and you want to analyze that data, and you have DNA sequencing data set, if you do not understand healthcare and if you do not understand DNA sequencing, it will be really difficult for you to make any headways with that data, because that data would have information that you have no idea. And this is not just only applicable to data science. This is to healthcare. It is applicable to other fields as well. It is applicable if you are trying to build a recommendation system for an online website, or it is also applicable if you're trying to do sentiment analysis for an online store, or for a movie, or for a restaurant. So if you any of these domains, you do need to have domain knowledge to become a data scientist. So this is what we believe as an organization, that you do need these skills to become a data scientist. Kate, would you like to add something to this?
Yeah, like Zia said, you cannot get away with not knowing any stats or at least linear algebra in order to be an effective data scientist. But notice how all 4 parts of being a data scientist are not, the pieces are not bigger than one another. That means that you need all 4 in order to be a data scientist. You can't just be exceedingly special in computer programming or just have domain expertise in order to become a data scientist, because you need all 4. And like Zia said, this is like a whole different type of learning situation, because traditionally we just went down one path, and now it's not possible anymore. Well, to be an effective data scientist is not possible anymore. Yeah. Then I would then like to start by asking, because whenever we go off to conferences also, the second question that comes up is, after we explain what a data scientist is, some companies also ask us, so where does the real value come in when you become a data scientist, right? So this is what we call a data science pyramid. It starts off by at the bottom with records, where we collect the data, and then we put them into charts, we clean, we aggregate, we visualize, and then we question the data, and then we write reports based on the data. This is the lower three is basically traditional data analytics, and what separates a data scientist from a data analyst is the next two parts of the pyramid, which includes prediction and action. Predictions is the most important part to a data scientist, where we actually start either recommending, we start understanding, we start inferring, we create predictions based on the data, classify the data, so on and so forth. And then an extension of the recommendation part, we then move on to actions, where we then say, okay, how do we make sure the data goes this way in the end, or how do we make sure our results go this way, or what should we say to the other divisions in our company, saying, okay, how do we use this then? That this is our recommendation part. Yeah. And then so when I was talking about the companies that ask us this, what companies actually use data science? That's kind of like the third question that people ask us. And Zia?
Yeah, so we believe that any company or any industry that has data can leverage data science to optimize, to predict, to get more value from their data. And as Kate was mentioning earlier, that traditional data analytics basically tells you what happened and why did it happen. So the first two components of the pyramid. And the second two components of the pyramid are what will happen, which is the prediction, and the fourth, the actionable insight, is how we can make this happen. And all those are applicable to any of the industries that you see on the screen. So for real estate, you can predict the price of the houses. From there, going on to cybersecurity, to aerospace, to finance, to healthcare. All these industries have large amounts of data, and they can all use data to get more value, try to understand and get a better understanding of their customers and how their customers, what are their buying habits and how they work how they process and the information and how they make sense out of it and how they make their decisions is all what these companies are trying to understand so that they can better serve their customers.
Right.
All right, so now I think at this point, guys, do you have any questions? Anything that we can help answer? This is actually the team that Kate and I work with pretty much on a daily basis. Irshad Khan is our founder. He has a wealth of knowledge in data science and artificial intelligence. And Jay Myers, City, Alan Fuller is our director for recruiting. He is responsible for anybody who takes our course and is interested in looking for a new profession, or they are a fresh graduate and they are interested in starting their first job. Alan actually helps them out, get their resumes right, their LinkedIn right, and then maybe get them in touch with a couple of companies so that he can make the introduction there. So this is the team we work with on a daily basis. Okay, so I guess time for a case study, Kate. So what are we going to do?
Today we're going to do a case study on identifying the car model. And as you see in your screen right now, there's a banner that says Porsche, guess the correct car for 0 down, 0 interest for a year, and then followed by a Jaguar symbol. So, so imagine you're in a car sales room and you see this banner. and this offer seems really tempting. So
How do I get it?
yeah, that seems to be the question. It's how do we get this? So you walk up to a car salesman and you ask him, how do I manage to get this incredible offer? And he tells you, I'm going to give you a data set that has the type of car, the price of the car, the age of the car, and the mileage of the car. And then using this data set, I want you to somehow answer with 70% accuracy in a different data set whether the car is a Porsche or a Jaguar. And you say, that seems pretty interesting.
So you have to actually do data science to actually get this offer. We cannot just kind of sign a document and get the offer.
Oh no, unfortunately not.
Oh, okay. So in this case, when you are trying to approach a solution like this, Kate, how do we approach it? Like we choose a tool and go forward with it?
So that's a very good question. Of course, we can just blatantly guess each one of the each one of the cars that he's given to us in the data set, and then just say, forget it. Who cares about previous data? I'll just guess it on my own. And there's actually a probability model that tells you that if you have a 50% chance of guessing the car correctly, and out of the 30 cars that you have to guess, you have to make 70% of them right, which is about 21 correct guesses and 9 wrong guesses using Python. In that formula up there, you see that we get basically we have a 1.33% chance of achieving the 70% criteria for the car offer purely by guessing.
Oh,
So
oh, so that means that like this offer is almost impossible to get because 1.33% chance is not a really good chance. So that means I have to do something different to actually improve my odds of getting this offer. And how I can do that is I can do that by actually using data science to help me out predict those cars, and by predicting them, hopefully I can get to a percentage which is higher than this 1.33, or and as high as hopefully above 70%, so that I can get the car. So how do I start? I choose a tool. In our case, we chose Python because that's the programming language that we use. And you basically import whatever you require. So you import your pandas data frame libraries, you import your NumPy libraries, you import other visualization tools that you have to. And then the first step, usually in a data science challenge or a problem that you're trying to solve, is actually you try to visualize the data. You try to see and figure out if there are any outliers, if there is any missing data, if there is any data that needs some attention, or that needs to be that needs to be handled before you actually start modeling. You take care of that, and usually visualization is a good way of doing that. Once you have visualized the data and you feel like that the data is now good enough that you can actually do model, you choose a model depending on what kind of a problem it is, and then you fit your data to that model. Once you have fit to the model, then you actually see what kind of results you are getting. You inspect your results, you see your accuracy scores or your RMSE values, whatever you are looking for, and then once the results are satisfactory and you are getting above what your threshold is, then you can implement that on the test data set. So this is kind of a high-level process that you do to actually solve a data science problem. And we are going to take the same approach, and we will try to solve the challenge that the salesperson gave us, which is predicting on the test data set how many cars are Jaguar and how many of them are Porsche.
right.
So yeah.
Yeah,
So how do you start that, Kate?
so first you start off by step 1, visualizing the data. As you can see in the top 4 charts there, you'll see that The variable that we want to identify, which is basically car, when modeled against all the other variables, price, age, mileage, and even itself, car, gives you two values. And since they are binary, this means that we are doing a classification model. And on top of that, I chose logistic regression because the way price, age, and mileage is graphed against car, I can probably fit a logistic line on to actually be able to capture most of those points. Therefore, that's why I chose logistic regression. And in the first
Yeah.
line of code,
Sorry, go ahead, Kate. My bad.
Yeah, so in the first line of code, we set our variables to be price, age, and mileage because those are our independent variables that we're using to predict car. And then we set y to be car, the dependent variable that we're trying to identify. And then from there, we import from sklearn logistic regression. Sklearn is a package just like pandas that has all the machine learning functions that you can possibly think of, from regular linear regression, multiple linear regression, PCA, SVM, even ensemble methods, and especially model criterias that come along with it. So using this package, I selected logistic regression, and then I fit the model according to my selected X and my selected Y's. And then I print out the accuracy score of the model. In this case, it came out to 74%.
Woohoo! So that means that we are above 70%, so we can get the 0% interest on the Porsche.
Yeah, definitely. It's
Oh, very
incredibly
good,
higher
very
than
good.
70%. So yeah.
So this shows the power of data science, that using data science with random guessing, where the possibility of getting 70% right was only 1%, we were able to actually get to 74% with data science. And we used a regression technique. Regression is type of an algorithm which have been there in statistics for many years, over 100 years. It's a very stable, very well and very famous technique in statistics. And using that logistic regression, we were able to actually predict the test data set with an approximate accuracy of 74%. So yeah, this is a very basic and simple example of doing a regression problem using data science. In the actual world, the problems have a lot more data, are a little bit more complicated, but this is a great starting point for people who are trying to get and see and get a flavor of what data science is and how it works and how it can help anybody where there is data. It can help that industry or vertical.
Okay, now that you've seen through an actual data science project or an application of data science at its simplest, we all know that most data science projects do go in more depth. So, Zia, where can people go to get more in-depth data science learning or training projects?
So Kate, that's a great question. Usually, what I'd like to say is that data science is not just your traditional learning, because in traditional learning you are actually just learning one kind of core subject. In data science, there are multiple cores. You do need to know computer programming. You do need to also know statistics, and you also need to have a domain knowledge. So this is a different type of learning, and we have introduced a concept of applied labs. And with applied labs, what we do is that we pair people in the class in a way that there is somebody from stats, there is somebody who is stronger in programming, and then there is somebody who has domain knowledge, and then there's somebody from the business aspect of it. And we group them together in one class so that when you are in the sessions, you get different opinions of the same subject or the same question from different types of industries or different types of people. That is where the real learning happens, because everybody, a computer programmer will come to a question from a different angle, whereas a statistician would come to the same question from a different angle. So you will see how different domains or how different people approach the same problem. So keeping all that in mind, what we have, the DevMasters have created, is a Mastering Applied Data Science program. This runs for 12 weeks, and in the 12 weeks is basically the Data Science Applied Labs is the first 6 weeks, and the project-based learning is the second 6 weeks. Our course is very heavily focused on hands-on learning and practical learning, as well as projects. So we get you to do at least 3 projects in the course in the project-based learning, and maybe 2 smaller projects in the Data Science Applied Lab piece. So all in all, you will probably do 5 projects with us. Now, before we start this course for the 12 weeks, we do get people who are newer to programming or newer to statistics. So we have something that we call it as pre-work. Pre-work is people who want to get their basics about programming or stats done. We do have sessions for those people so that they can join them, and then when they start the program, they actually have gone over the concepts or gone over the basics in the pre-work for stats as well as for coding, and because that's an important aspect of it, so that you are not concerned when you get into the actual program about that. So this course runs for 12 weeks. It's designed for professionals, so it runs on the weekends, Saturday and Sunday. So you don't have to leave your job to actually take this course, or if you're interested in switching a career, you don't have to leave your job and start and do a Monday to Friday. You can actually do it on the weekends. Now, we do understand that there's life happens, and there could be a situation where you cannot attend a class or maybe a couple of classes or a weekend. So we allow you to come back and repeat the course at no additional charge for as many times as you want. So what we like to call it is a lifetime membership. So this course has a lifetime membership. So once you've taken the course, if you missed a class or if you didn't get the concept, and if you want to come back and review the course, you are welcome to come back and do it. Sometimes we introduce new topics, so if there's a new topic, you are welcome to come and join that course. So this is one of the trainings that we offer. The other course, so this is a 3 months one. The other option that you have with us is a 7-day, 7 consecutive days. So it starts on a Sunday and ends on a Saturday. So this is a 7-day course which is designed for more people who are already in the industry or have good background in coding and in stats, and have good knowledge of the domain, and they're interested in actually just enhancing their skills. So this is designed for people who want to do it in a really short time at a very high speed. This is 7 days consecutive. Again, comes with lifetime membership. So if you take this course once and if you want to come back and repeat it, you can absolutely repeat it. There is no additional charge for that. And once the course is done, once the materials is delivered, you do some projects within those 7 days, so that you get some hands-on experience with that. And you will do 2 Kaggle projects during those 7 days of the content. Again, it is designed to be a more practical oriented and has the same concept of applied labs in there, so that you can get different opinion from people who are in different domains for the same question. So that gives you an idea of how a business person would look at this question, and how a statistician would look at the same question, or how a computer programmer would look at the same question. Now, Kate, what kind of topics do we cover in this 7-day course?
Oh, yeah. We're going to speed run through a lot of topics, actually. So on the first day, we're actually going to introduce you to data science, which is basically we're walking through Chris DM and some initial portions of data science and walk you through exploring data using techniques such as an introduction to pandas and a little bit about how you can manipulate some data points and data frames actually. And then we move on to data 2, which is a lot of, now we say, okay, let's actually mine some data using NumPys and pandas again, where we'll actually find some sources of data out there on the web for you to scrape as an example of data mining. And then we'll end the day by saying, okay, here's now a data set that is considered a time series data set, and let's utilize what we've learned so far in the last 2 days to create a miniature project out of it for time series. And then day 3 is where all the fun starts, because the last 2 days was just data prepping and data cleaning. Day 3, you actually you start learning some initial machine learning concepts such as linear regression, simple regression, multiple regression, and then we move on to logistic regression, which is part of the advanced machine learning concepts because it's a classification, and then we move on to some more classification algorithms such as naive Bayes, decision trees, random forest. There's a whole bunch. Day 3 is actually a very long day but it's very, very useful. Then we move, and then since the last 3 days will probably burn people out, day 4 is kind of like a breather where we do 2 projects. One of them is estimation, the other one is classification, where you would then be able to review what you learned in the last 3 days and then actually see where you need help on and what an actual data science somewhat to almost the end looks like and how it feels and such. And then after that, you'll be fresh and ready to go for day 5, which is moving on to what we call the distinguishing parts of being a data scientist, where you learn about recommendation systems and then natural language processing and sentiment analysis, where you now consider text as data, where this data can actually tell you how your customers are thinking or so on and so forth. And then day 6 is another big part about being a data scientist, which actually creeps a little bit into artificial intelligence actually, with big data with Spark, and computer vision with a miniature project, and then deep learning. And we wrap off the 7-day course with, again, a project, two projects actually, where you decide which 4 topics in the last 2 days that you feel you really, really liked. So project 1, it can either be natural language processing or a recommendation system, and project 2 can be a computer vision or a deep learning. And yeah, that about wraps up the whole 7 days. Of course, the 12-week program is a little bit more spaced out if you feel like this is going too fast, but again, I'd like to remind you that our courses do have a lifetime membership guarantee, where if it's too fast for you the first time, you can definitely come back again and utilize learn the same thing over again.
Yeah, so that's it. Sorry.
Yeah, with different people actually this time probably, because yeah.
That's a lot of content for 7 days for sure. But again, as Kate was saying, that it comes with a lifetime warranty, lifetime guarantee kind of thing, so you can come back and take the course again. But it's some great content, lots of information. So if you are up for it, get ready, and we'll be happy to have you on board.
Yeah. Then if you need some help getting on board, there's some financing options. We have in the first column, we have flexible payment options, where we'll actually be able to help break down the 3 into 3 payments for the program. Note that this is only available for the 12-week program, because we'll be able to help you break it down further. In 7 days is actually not that possible. And then for scholarships, we have a veteran scholarship for veterans, scholarship for students, which is about 5 to 10%. These require documentation, of course. And then if you're part of a corporation and you feel like, say you wanted to bring this to your company instead, we have a group discount and a one-time pay discount also, if that helps. Yeah. And then here are some testimonials from some of our past students. We have people from biostatistics, logistics, some software engineers, some in finance and retail. So it's not just your average computer programmer or just statisticians running through this program. There's a lot of people that see the benefit and uses of data science, so they hopped on it as soon as possible and went through our program and are very happy to have gone through our program. Yeah. And then here are some pictures of some of our classes where you see some of our students, our setup, and how crowded it sometimes gets, but at the same time how small the classes are also. And it's a great experience for those who went through this. It shows where they used it and how they've learned it, and yeah. And, yeah, so Zia, if people really like what they've seen so far, what is considered the next step?
Yeah, so good question, Kate, again. If you like data science, if you are interested in becoming a data scientist, and you are interested in finding out a little bit more about the course, or you're interested in actually attending an advanced session, you are welcome to reach out to us. Kate will be sharing our contact details with you shortly. So you're welcome to reach out to us, and we will be happy to. The advanced sessions are more by invitation only, so we'll be happy to send you an invite for the advanced session. The advanced sessions are typically held in Southern California, in the Orange County and the LA County area, but we are opening it up to other places as well. So if you are interested, please reach out to Kate, and we'll be happy to send you an invite for the advanced session. The other option, so that's one thing that you can do with us. The other option is that if you have a general question, and if you wanted to talk to somebody about how to approach it, what are your learning options, what's the next step that you should do, and those kind of questions, you are welcome to actually again reach out to us, and we'll set up a time with one of our team members who will be happy to answer any questions for you, and maybe give you any thoughts that they have on that topic. So the second option that you can have is that you can book a time with one of our team members and discuss whatever you have on your mind for data science. The third option, that how you can engage us, is by if you have a project in mind that you want to do and would like us to help you out with that project, we would be happy to talk to you about that as well. We call it as a POC, so we'll be happy to talk to you about any proof of concepts or any projects that you have in mind that you want somebody else to do it for you, or somebody else to help you out with that. So that's the third way that you can reach out to us. So these, Kate, I believe, are the next steps typically for anybody who's interested in data science and would like to pursue this.
Okay.
So I guess, Kate, that's it for the questions. So now, again, thank you very much, everyone, for joining our webinar. I hope it was informational for you. I just want to remind everybody that if you still have any more questions, please feel free to reach out to us via this email, contact@thedevmasters.com, or you can also reach us by this phone number, 1-866-340-1375, and you can talk to any of the team members here and send your questions there by email as well. Thank you again, guys, and have a wonderful day. Look forward to talking to you soon.